and welcome to TFI CAD Tips! Right, you've seen the title of the video, you know this is a benchmark video and you're here to see the results. So what I'm going to do is jump straight into them, and then afterwards, that's where I'm going to waffle on and talk about the results, what they mean, make sense of them, and talk about why some of them are quite astonishing. Now the two PCs in question will be detailed during the benchmark tests, you'll be able to see the specs of them, but just in a nutshell, one of them is a Dell Precision Tower T5810, it's a current gen Precision Workstation costing $6,189. The other workstation isn't even a workstation, it's a gaming PC, roughly costing around $2,000, and these two are being put head to head on CPU only specific benchmark tests. Xeon versus i7. Here we go. So this first benchmark test is just Inventor starting up straight from a reboot, closing it down immediately and then reopening it. The second time you reopen Inventor, it's always a bit quicker because a lot of its application files have been cached in memory. It doesn't really mean much because it's not indicative of how Inventor is going to perform for the rest of your usage. However, it does give you a kind of overall feeling as to how fast the PC is reading and writing application files. So it's just an interesting test to see whether or not that processor, that 10-core 3.5 GHz processor, is going to be significantly better at performing something like this than the i7. And as you can see, there's very minimal difference, 0.3 seconds between the two. Benchmark number 2 is really getting into it now, so we're opening up an assembly containing 1,154 unique parts, cold open from reboot, nothing's cached, everything's migrated, saved and updated, loading it into full mode, not express mode. The two assemblies are absolutely identical across the two PCs, it's the exact same dataset in the same state. On paper, the Dell workstation should win this one hands down because all the components being used here are of a higher quality and of a higher spec to the gaming PC, and also at this point Inventor uses multi-core technology on the Xeon, so those 10 cores at 3.5 gig, 35 GHz of processing power should beat the 4-core 4.4 GHz on the gaming PC, faster solid state drive and higher clock speed RAM, but as you can see the gaming PC wins it yet again by around 3/4 of a second. Benchmark number 3, right, this is the first of the long benchmarks. This is placing and creating two high detail drawing views of the assembly used in the last benchmark test. 1,154 parts placed onto two different drawing views. Now again, on paper, the Dell should win this one hands down because it's common knowledge that placing and creating views is again another multi-threaded operation within Inventor. So that Dell Precision Workstation with its 10 cores and its 35 GHz of processing power should easily beat by a substantial margin the 4 cores and 4.4 GHz, 17 plus gigahertz total processing power on the i7. So the Dell's got over double the processing power in total to play with when it comes to multi-threaded operations. So you'd think again that this would be an easy win for the Dell. And you can see it is quite a hefty drawn view, so I've picked something here which is really going to tax both these systems. So we've got a bit of time waiting for the PC to load the components, we've got a bit of time for it to calculate the views and then present them on screen. And again, it's neck and neck up until this point. The gaming PC has just started to compute the views at this point, and it completes them, I wouldn't say well before the Dell, but the gaming PC again wins this one by, I would say, a substantial margin. Benchmark number 4 is taking that last assembly again, the same one, and then placing it into a new assembly as a sub-assembly and then allowing it to ground at the origin. You can maybe see what I'm doing here. The benchmark tests that I'm using are typical operations that you'd hear a user complaining about their PC being slow to do. Placing drawing views, opening assemblies, placing assemblies. Those big bulk heavy operations that would normally tax your average computer, and running those on this high-end equipment to see which one does it the quickest or if there is any difference at all. And I was at odds as to what point to stop this benchmark, because whenever you place an assembly, there's always a little bit of stuttering at the end of that place operation. So at what point does it finish? So what I decided to do was to let them finish, and then at the point where I was able to right click and then see the marking menu, so I was able to perform a further command, that would be the point in which the test would conclude and the timer would stop. So the Dell Precision Workstation finishes first. You can see the browser's populated, but the gaming PC, the browser took a few seconds more to populate, so the Dell one wins this one by a couple of seconds. And run the final test, benchmark number 5. This is enabling all visual settings within Inventor Turning on ray tracing, allow basic ray tracing to complete, turn on high quality ray tracing, and then stop the timer when they hit smooth. This is where, on paper, the Dell should storm it. All 10 cores at 3.5 GHz going balls to the wall on ray tracing should win it hands down. Now, there's some interesting things to watch here. On the right-hand side, the timer is quicker than the Dell PC. So the gaming PC is approximately 7 to 8 seconds ahead of the Dell, and that's because I started the timer when basic ray tracing began, and going through all the visual quality settings and then getting to a point where I'm able to hit that ray tracing button and enable it. The gaming PC was able to do that 7 to 8 seconds faster than I was able to do that on the Dell. Again, that's quite significant. Now, what's also worth noting at this point as well is that ray tracing, after 110 seconds so far, still hasn't even turned on. It still hasn't enabled. We've got a bit of a delay first before ray tracing switches on and begins to calculate. This is just the pre-work up until that point. So both PCs, even that Dell with its 10 cores and its 3.5 GHz and its 35 GHz of processing power, still can't switch on ray tracing after all this time. It's still neck and neck with the gaming PC. The gaming PC, after 175 seconds, 175 seconds, is started the basic ray tracing, and now it's on to high. The Dell still hasn't even started basic ray tracing yet. It has now after 195 seconds. The Dell's finished the basic, and now it's starting on the high ray tracing. So clearly, up until this point, those short burst operations, the gaming PC is just storming it. It's winning it hands down. But now at this point, we've got all the cores going nuts. Absolutely nuts. This video is speeded up to around about 300% as well, so you should see visibly on the left hand side that ray tracing bar progressing much quicker on the Dell PC than it does on the gaming PC. And this, out of all the tests, is the only one where you're able to see a benefit of having that high-end Xeon with all those cores and all that processing power. Up until this point, there's been minimal benefit out of having that Xeon. So the Dell's taking it. You can see the bar's much further ahead now than the gaming PC. Even though the gaming PC started before the Dell's just overtook it with all those cores and it's winning it. So I think the conclusion from this test is that anything short burst, anything sort of small scale, that's only a few seconds, maybe a minute or two long, those cores don't matter. They really do not matter. Even if you're using multi-cores, it's just not going to get a benefit. It's only when you're using long-term processing power is where you're going to see a benefit of having all those cores. So the Dell's finished 387 seconds, 6.45 minutes. The Dell finished its ray tracing and it hit smooth. The gaming PC is still going. So 6.45 minutes, that's the Dell complete. And overall, I think if you were to let the ray tracing carry on all the way up to, I think it's fine where it stops at. It would have been around about 8 to 10 minutes, something like that. So you're looking at here, even on an operation this big, you're looking at a time saving of only a couple of minutes, which is still very significant if you put that over a long period of time. But there's the results there between the 10 cores and the 4 cores. Okay, let's talk about those scores, shall we? Right, what I'm not going to do is give out any statements that I believe are fact or any recommendations or conclusions. All I can do is just show you the results, show you what went into getting those results, as much information as I can so that you can then make your mind up from what you've seen with your own eyes. First, starting off with the Dell PC, which was the video on the left hand side of the screen. It was a Dell Precision T5810 workstation, current gen, as what you can buy as of today. The 5810 isn't the highest end workstation that they do. That's the 7910, where you can stick in dual Xeons and liquid cool it and put in 4 graphics cards. This one's sort of mid-range, I would say, but the components inside there are very good. They are really good. It's a $6,189 workstation, for crying out loud. It's expensive and it's high-end still, even though it's not a 7910. Right, the CPU in the 5810. This PC was going to a guy who mainly does FEA work, but he also does normal Inventor operations as well. So I had to pick a CPU where we had a good use for FEA and a good use for normal Inventor work. So I had to get a compromise between clock speed and core count. So all these Xeons available in this chassis, I thought that this one here, the E52687WV3, would have been the best option at the right price point. It's got 10 cores, 3.1 GHz clock speed, which turbocharges up to 3.5 GHz, excluding hyperthread, and you've got 35 GHz of total processing power there. It's also got quite a good onboard cache as well, so it's got 25 meg of onboard cache. Now, all the other CPUs in the list kind of give and take when you go to each one of them. So if you were to go one level up, the $330 increase in price, you're losing hyperthreading, you're losing 5 meg of cache, you're gaining only 100 megahertz in clock speed, which isn't really going to make that much difference, but you're losing 2 cores. And those 2 cores could make a massive difference on those long operations, those prolonged periods of doing FEA. So that wasn't really an option. If you go one level up again, you've got 12 cores, but then you're losing, 500 megahertz of clock speed, and then you're putting $510 on top of the price, but you're losing that huge amount of clock speed. So that wasn't an option again. Going down, you can pick a higher clock speed. You've got 3.7 gigahertz here, which probably turbocharges over 4 gigahertz, but then it's only got 4 cores. So that's not really going to be any good for FEA. It will be good for FEA, but 10 cores is a lot better. So I thought that for FEA and Inventor use, this one here was the best compromise for clock speed, core count, and at the right price point. So that's why I went for that one. Right, Windows operating system. Yes, there was a difference between the two. The gaming PC was running Windows 10. The Dell was running 8.1. The reason for that is because the Dell PC is going into an environment where Windows 10 is, unfortunately, for I don't know what reason, is just not certified yet, so I couldn't pick it as an option. It would have been great if I could, just to rule that out. However, having said that, I can't imagine, and I'm saying this out of pure ignorance, I can't imagine that Windows 10 brings so many improvements to file access and how it addresses drivers and hardware that it would bring a $2,000 gaming PC in line with the performance of a $6,000 workstation running Windows 8.1. I can't see that happening. However, if anybody knows of any reasons why it might do, based on purely the tests that you've seen in here, I'm not talking about other things, I'm talking about purely the tests that you've seen in this video, then by all means, if you know more about that than I do, put a comment down below and let me know all about it. Totally open to being told otherwise on that one. Right, the graphics card in the Dell workstation didn't come into play at all during the tests. However, it was an NVIDIA Quadro Maxwell 4000 8GB professional grade workstation graphics card. This is by no means the highest range Quadro that they do. That'll be the M6000 currently. But the M4000 is still a really good card. It's not entry level, but it's not the highest one that they do. There's not much that you can do with Inventor that will bottleneck the M4000. I've done separate video benchmarking tests ready for another video, and the M4000 is, you'll have to see it to believe it, but it is more than enough for everyday Inventor use. So that's what was in the Dell PC. Moving down the list, the chassis, again, this didn't come into play, but it was an 825 watt PSU. That really didn't matter. The RAM, it does matter. It has 16 gig of ECC 2133 MHz DDR4 ECC RAM. The quantity of RAM never came into play. It was never a bottleneck in any of these benchmark tests. However, the grade of RAM that was used in the Dell was a far higher spec than what was in the gaming PC. The gaming PC didn't have ECC RAM, it was DDR3 and it was a lower clock speed. It was 1600 megahertz. The gaming PC had 32 gig of RAM, but like I said, the quantity of RAM never really comes into play here. Having more RAM doesn't make your PC faster if you're not using it all. It just doesn't. It doesn't work that way. So that was never a bottleneck. The hard disks inside the PCs should have been important. That really should have made a big difference. The Dell PC had a 512 gig PCI Express 16 M.2 solid state drive. This is a high-end solid state drive. It's by no means the highest one that you can buy. It's not the most expensive or the fastest performing one that you can buy, but in terms of Crystal Mark bench tests, it was getting around about 2.5 gig per second read speed and 1.5 gig per second write speed. The gaming PC had a standard SATA 3 solid state drive in there, which was 500 megabytes per second read and write speed. So the Dell solid state drive was around about ×4 faster than the gaming PC's hard drive. So anything that involved reading and writing to the hard disk, the Dell PC should have just won that hands down, but wasn't necessarily the case. And the last spec, which doesn't really make any difference whatsoever, is the Dell PC had a secondary 1TB mechanical 7200 RPM drive in there, which just never really came into play at all. So that was the Dell PC. Now the gaming PC, the CPU that it has was the i7-4790K processor. Now that is a consumer grade $300 processor, 4 cores, turbochargers up to 4.4 GHz with a 4 GHz base clock speed. Like I said, it's a $300 consumer CPU chip up against what I think is around about $1,500 Xeon processor with 10 cores. Did you see in any of those tests a $1,300 or $1,200 difference in performance between the two PCs? I'll leave that one up to you, but that's what we're looking at here, a $300 chip versus a $1,500 chip. I mean, just look at the prices. If you were to take away this chip and put in just one of the lowest grade Xeons that they do, you're adding $1,800 to the price. Go and Google the E52687WV3 chip and see what you can buy it on its own for. And look at the price of that and then see whether that is going to be worth buying over the i7. So that's what we're playing with here. So the gaming PC had Windows 10. We've talked about that already. It had a NVIDIA GeForce Gaming 970 graphics card in it from MSI. The graphics card again didn't come into play in this test, but that's what makes the gaming PC really. It had the GeForce card in there. Also, the rest of the components in there are gaming quality. The motherboard is an Asus Maximus V2 Ranger motherboard. It's Corsair Vengeance RAM, non-ECC. It's got, you know, the entry-level solid-state drive in there. It's got it's liquid cooled, but that shouldn't really make much of a difference on these benchmark tests. But yeah, that's the gaming PC in a nutshell. So let's have a look at the scores that we saw, and let's just pick apart the scores. So the first one was the startup time. Now this test was pretty meaningless, but I think it's about right. We've got the Dell PC starting up in 24.3 total seconds. So that's how long it takes Inventor to start up from a cold reboot, shut it down, and then reopen it. 24.3 seconds versus 24.6 seconds. Now, it's only 0.3 of a second difference between the two PCs. So again, just think about the grade of components in the Dell PC versus the grade of components in the gaming PC. Would you have thought you'd have seen a quicker time, even if it doesn't matter, even if it's, you know, it doesn't make any difference whatsoever in real life? Should you have saw a bigger difference between the two? I think I would have. I'm surprised that it wasn't a bigger margin, but the Dell did win that one either way. Now the second test was the assembly load time. Now this one is where I was genuinely astonished. This was Inventor opening up a 1,000 plus part assembly, and I was expecting the Dell to just go to town on the gaming PC here, because loading a large assembly, it's loading components into RAM, and the Dell PC's got a higher grade of RAM in there. It doesn't have as much, but we weren't taxing the RAM in terms of its quantity. So it's got faster speed RAM. In terms of reading files from the hard disk, it's got a faster hard disk, a significantly faster hard disk. It's up to 4 times faster than the gaming PC. And also processing all those operations, you've got 10 cores. Now opening an assembly, Inventor does use multi-core technology at that point as well. So I'm just astonished that the gaming PC actually won this. I'm more astonished that they were even in the same ballpark. I was expecting the Dell PC to have at least shaved off 5 or so seconds from the gaming PC. I was astonished that they were both within the 27-second region. Even more amazed that the gaming PC won this one. So there's always going to be a level of tolerance around these sort of scores, because it's just a manual timer. I'm manually stopping it when I see the benchmark finishing. So it's far from scientific. So you're still talking about, you know, anything up to a second in tolerance between the scores. But that's still quite a surprise. Okay, the third test was the multi-view creation. Now this was possibly the most surprising score out of the lot of them. I was shocked when I put the scores together and compared them and I saw this. It is common knowledge, it is very well known that multi-view creation and drawing view creation is one of the areas of Inventor that definitely uses multi-core. It's whenever you have a conversation with your CAD supplier, does Inventor use multi-core? Well, it does on its drawing views and FEA and rendering, blah, 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 blah. Drawing views. You'd think, on paper, a Dell PC with 10 cores would just go balls to the wall on drawn view creation and just pull the pants down and spank the backside of a gaming PC with only 4 cores. Evidently not. Evidently not. We've got 166 seconds for the gaming PC, and we've got 172 seconds for the Dell Precision Workstation. That's a significant gap. I can't explain why the Dell took so much longer to create those two views than the gaming PC. We're talking about the exact same dataset, the exact same circumstances, the only difference being the Windows operating system and the hardware. The dataset and the operations leading up to creating the views was exactly the same. So I'm just shocked and stunned that the gaming PC took this one, given its it's just inferior specs all around in every department. Okay, the fourth test was placing a large assembly into a subassembly and then grounding it at the origin point. Now, this one was a funny one. Now, the Dell one's obviously won it by 2 seconds. I'm still quite surprised that they were within the same ballpark score. I'm hesitant to rely on these scores too much because at the end of placing that large assembly, they both finished at approximately the exact same time, but there was a tiny bit of stuttering at the end on the gaming PC where the browser didn't populate, and that just added those couple of seconds on the end of it. Now, I don't know what happened there. It could have been something else going on at the time on the gaming PC that just, took a little bit of processing power away from it. I don't know, but either way, the Dell won, and if you were to ask me beforehand which one I thought would win, obviously I would have said the Dell. It is worth noting as well, I should have said this earlier on, but the Dell PC is completely factory settings. There is no other software on that PC other than Autodesk Inventor and the screen capture software. That is entirely the only software that's on there. When I received it from the factory, I unboxed it. I uninstalled the Dell software that comes preloaded onto it, which isn't that bad for Precision Workstations. It doesn't have that much on it. But I took that off, Inventor went straight on, and then I benchmarked it. So the registry wasn't cluttered, the hard disk wasn't cluttered, it wasn't fragmented, it was straight from the factory, fresh as a daisy. The gaming PC, however, that's had Windows on it for a good year or so now. So that is a little bit cluttered, and well, you can see it's kept up quite well with the Dell Precision Workstation, which is pretty clean. But that's the power of a solid state drive, regardless of whether it's just SATA 3 or whether it's M.2. So those are the results for the fourth test. Now, the final test wasn't really much of a surprise. This is the multi-core ray tracing. What was a surprise, though, was the point leading up to high ray tracing being enabled. The gaming PC just stormed that one. What I had to do leading up to turning on ray tracing was enable shadows, reflections, perspective mode, and then turn on an image-based lighting environment, and then turn on ray tracing. And all of those steps were quicker to be done on the gaming PC. The Dell PC was lagging behind by about 7 to 8 seconds. So that was quite a surprise. Those short burst operations seem to be quicker when you've got a PC with a higher clock speed. But then once high ray tracing kicked in and all 10 cores were able to just pick up speed and go nuts, you saw the Dell PC just raced into the lead, and it finished a good 2 minutes quicker than the gaming PC. So I think my conclusion from this, my personal conclusion from this, is that if you are going to be going for just a basic Inventor PC for normal modeling operations, even for large assembly design, I think a higher clock speed, as high as you can physically and possibly get it, is always going to be best. Now, that was always common knowledge, but what I've done in this video, what I hope I've done in this video, is at least gone some way to prove that and demonstrate that. Whenever you're doing operations that require horsepower over prolonged periods of time, if you're doing a render or an FEA analysis and you need to leave that on overnight, we're talking that big, that's really, as far as I can see, the only time where you're going to get benefits out of having a beefy behemoth of a CPU with multiple cores and a high clock speed. So that's pretty much it for the CPU benchmarking tests. Now, it's all manual, like I said, it's all open to scrutiny, it's all open to being passed. By all means, put some comments down below if you've got anything to say on the matter. What I'm not doing, I need to just make this final point, absolutely categorically not beating on Dell at all. Even since doing these tests, I've bought Dell Precision Workstations for the office that I'm in, purely because they're supported systems. The gaming PCs, they may perform better marginally, but you can't realistically put a gaming PC in a professional drawing office. You still have to go for those Xeons, you still have to go for that ECC reliable RAM and those Quadro cards, because Autodesk, when they perform tests on their new software that comes out, they only benchmark test the Quadro cards and the FirePro cards. They don't benchmark test or certify drivers for gaming cards. So if you want to be proper, if you want to be certified and supported, I won't say supported, but if you want to be safe, you want to be going still for those Precision Workstations. And after all said and done, even though the gaming PC sort of came out better in these benchmark tests, I wouldn't say that it's enough of a margin to justify going down that route and picking a gaming PC. The Precision Workstation, this one in particular, was still pretty powerful. There was no bottlenecks whatsoever, and it's as fast as if anything, the software on this hardware was the bottleneck. So that's pretty much it, guys. Thank you very much. Like, comment, subscribe if you haven't done already for more future videos. Doodles!